Hello everyone, my name is Abhinav and I'm going to talk about how to make Org-Babel reactive. So reactivity here means reactivity in the sense of reactive notebooks. So if you used Org-Babel, you might also have used Jupyter notebooks, which are basically notebooks primarily for Python programming, where you have these text and code blocks interleaved, and then you can execute every code block independently, and then you control the order of execution manually, or you can just run the code blocks from top to bottom. But with reactive notebooks, what happens is that there's another way of running, which is basically by having all these dependent code blocks automatically get executed where whenever you make a change. So, for example, if you change a variable, everything else that's dependent on that variable will be executed automatically. So, I'll show you an example of what that looks like. Right. So here's an example reactive notebook. So this is called Observable. Observable is this tool made by the creator of D3.js, which is a famous JavaScript charting library. So here the interface is very similar to Jupyter Notebook. You basically are having these cells, and each cell could be a text cell. Like here, this is a Markdown cell, and then there are these code blocks. Now each code cell is basically defining a variable. This is important in reactive notebooks because each cell is connected to other cell via this variable usage. So here data is defined, then there's filtered, which is defined, which is dependent on data, and then this plot is dependent on filtered. So now in a classical notebook, what I will do is, like, if I change something here, let's say from 1 to 2, I will have to run this and then run this plot block again to make the change be visible. But in a reactive notebook, what happens is, like, I can just change this from some value to some value and then execute, and then every descendant is also executed because that's how the reactivity works. You change this variable, so this should also be changed because this is dependent on this variable. Now, this is really helpful if you have a very complex and messy notebook, which is what actually happens in reality. You end up doing an exploratory analysis and you have these code blocks lying here and there. And then you change something, and then you have to just keep something in your mind that if I change this, I need to run these 5 code blocks again to finally get to the result that I want to see. And stale state is very is a lot, causes a lot of issues in Jupyter notebooks. So this is really good for reactivity, sorry, for reproducibility, but this is also really good for just having this exploration that you're trying to do. For example, you're changing something and it's really easy to just see that change happening in real time in your outcome variables, right? So I was wondering how to introduce this reactivity in org mode, and here's how it will look like. So this is a demo org mode file. There are many Org-Babel blocks here. So you start from here. Let's say this is a code block. It has a name, and then there's this another code block which is dependent on the previous one, as you can see here, and so on. And then finally there's a plot here, which is a GNU plot code, and you can see the image here. Now, what happens usually is that if I change this value from, let's say, 113 to 112, nothing happens on its own, right? Like there's an extra step of execution that I'll have to do. So I do that, and then the value is changed. Now, the problem is that only this value is changed, and if I go down and see the image, nothing will have changed. So what I can do is basically, one very simple thing is that simple trick is to basically enable a hook, like add a hook. Whenever you're saving the buffer, you just run the whole buffer again, like run all the code blocks automatically. Now if you do that, you can basically make a change somewhere, and then you can see how everything else is changing. It gives you some sort of reactivity, but there's still like a lot of computation that's being wasted. You might not want to change or run this code block again when, let's say, something down there is changing. So to counter that, you can actually add caching. So if you add caching to any code block, that code block will only be executed again if that code has changed or the input variables have changed. No, but the other problem is that you don't want caching to be enabled for a lot of cases where the code block is actually dependent on external state, like for example, some sort of randomness or time. So caching also is, kind of, it's like an important thing to use, but it's probably not giving you the complete answer. So what we can instead do is basically figure out the whole computation dependencies here. So let's say if I look at this buffer, here's how the whole all the blocks are connected. So as you can see, the plot code block is dependent on C, and then legend PG, and they themselves are dependent on these other nodes. So when I make a change in B, I only want B to run, and then C, and then plot. I don't want anything else to run. So what I did was I wrote a small minor mode for org mode, which does exactly this. So whenever you are in a code block and you're making a change and then you save it, it will just follow the trail from that code block to every other descendant which is going to be impacted, and it just runs all of them, and nothing else gets executed. So to see it in action, I will just enable that mode. Yeah, right. So now here, if I change this 113 to 112 and I save, this code, this variable gets changed. It's the same value because I did not update it again. And you can also see B also got changed because it's just following all the execution order, and so on. The plot also got updated. We will be able to see more clearly once I change something more substantial. So here's another variable. So I added a small toggle button here, which is again part of the minor mode. So since this is nil, if I toggle it, it will become true. And this variable dictates whether the plot will have the legend or not. So if I toggle it to be t, uh, now it's t, and you can see that the plot has legend that's visible. If I toggle it back again to nil, the legend is gone. Now this is nice. This already pretty helpful for me. But what we can do is like we can make it even better. So one of the nicer ideas from these reactive notebooks is this idea of having an infinite canvas. So where you don't look at the document model, you look at look at the whole document as like a canvas of multiple connected documents. So one good thing that happens there is that you can basically have a piece of code somewhere, and then piece of code somewhere very different position in the document, but you can put them together in the canvas and then see them side by side. So here also, like, let's say if I want to just have this image shown up at the top, let's say, what I can do is like I can pop this out, which opens a child frame, and then I can just go here, and this child frame is showing the same image, so there's no change. So if I toggle this variable here, you can see that the image is updated. If I toggle it back to nil, the legend is gone. And you can obviously, you can in make a lot of things come up as child frames. This is the same image, so even if you go down to the document, you will see the same image. So yeah, this is what I have right now. I'm definitely looking forward to like making it more useful, probably including more kinds of child frames, maybe like making the whole document an infinite canvas. All right, so that's the talk. If you're interested in the code base, here's the homepage for the project. So the next steps for me are basically making my workflow easier in Matplotlib, which is Python based library, and D3.js, which is for JavaScript. For the JS thing, I might have to add the interactive JS child frames, and I am also looking forward to like building something which can replicate the work of the observables infinite canvas, because that's something which I found really useful in my work with just JS visualizations. So yeah, happy to take questions on Etherpad, and thank you for your time.